The following content is meant purely for educational and informational purposes and should not be relied upon as financial, investment, legal, tax, or any other professional advice. This is the Fundamentals Podcast, where we demystify crypto and help you navigate this ever-evolving internet-native economy. In this episode, we're joined by Dominic Williams, the founder and chief scientist at DFINITY, a major contributor to the Internet Computer blockchain. The Internet Computer is a general-purpose blockchain that hosts Canister smart contracts. It's designed to provide a world computer that can replace traditional IT and host a new generation of Web3 services and applications that run solely from the blockchain without the need for traditional IT. It can also play the role of Web3 orchestrator by interacting with traditional blockchains. In this episode with Dominic, we talk about the big vision behind the Internet Computer and what the journey has looked like from initial idea to launching mainnet. Dominic walks us through the main technical innovations that have needed to be introduced to enable this vision for a true world computer, and we speak about the compelling real-world use cases that the IC can facilitate and how adoption has been progressing. Over the next hour, we cover the evolution of smart contracts, identity authentication, open internet services, building tamper-proof, autonomous, and sovereign infrastructure, and much more. Tune in for a great discussion about restoring the internet to its open, innovative, and creative roots. What's your number one coping mechanism during these heat waves? I still haven't found one myself.
So basically it gets to peak heat and then you open the windows, and I just learned this from the design guys earlier, and then you open the windows and the breeze makes it better, but you can only do it about 3 p.m. 4 p.m. Before that, it doesn't help, makes it worse. Or it's cooler down here actually, so you could potentially hide in the basement.
Oh, that's good to know. I need to start timing my window openings for sure. Thanks for that tip. Let's dive right into it. Welcome to the Fundamentals Podcast. It is really great to have you on.
Thank you for having me, Oscar.
Now, being the founder and chief scientist at DFINITY, which is the biggest contributor to the Internet Computer blockchain, I'd love if we could just start off with you kind of walking us through what the IC's core value proposition is.
So the big vision is that the world doesn't build things using legacy IT, but builds things on the internet itself. And the internet is a public network. It's a decentralized network that connects everybody and everything. And we also want it to be the platform that systems and services are built on too. And of course, this particular platform enables you to build with an evolution of smart contract software, which is tamper-proof. You don't need to protect it with a firewall. Can't be infected with ransomware, unstoppable, like the internet itself, and like any other blockchain, easily composed, so people can collaboratively build things who don't necessarily trust each other or work together, processes tokens, so you can process value as data, and several other important things. Not least, actually, that one of the biggest costs in IT today is actually personnel, and it derives from the complexity of legacy IT. So the world spends $5 trillion a year on, it's a simply staggering number, right? And 36% of that is IT personnel. So if you can reduce complexity 75%, and we think we can reduce it much more than that, you're creating potential savings of $1.35 trillion. So we see blockchain as a new kind of cloud, which can provide a complete alternative to the legacy IT stack. And the legacy IT stack most predominantly in use is cloud and the software you run on it, like databases and Kubernetes and web servers and things like that. And we want people to build in a completely new way on the internet using Canister smart contracts. And as a result, the Internet Computer has to perform at a level far beyond traditional blockchains. That means that people need to be able to store vast amounts of data on the blockchain. The blockchain needs to be able to process vast numbers of transactions very inexpensively. The code on the blockchain needs to be able to serve user experiences directly into web browsers, because the intention is that people can build anything at all directly on the blockchain itself in order to derive all those kind of advantages that I just mentioned. And of course, with respect to Web3, if you build your system or service on the blockchain from Canister smart contracts, that means that you can put it under the full control of a special kind of DAO called a service nervous system and create something called an open internet service. And we got two main pushes. One is towards the Web3 world. We want people to stop building on Amazon Web Services, because the predominant pattern today is that people will have heard built on Ethereum, built on Solana, built on Avalanche, but they may not realize that the language actually means something a bit different than what it might appear to mean on first look, right? So when somebody says built on Ethereum, built on Solana, built on Avalanche, they don't mean that this Web3 service, this metaverse, this game, this social media is actually built on the blockchain. What they mean is typically it's built on Amazon Web Services, where 99.99% of the data and computation lives, and where the user experience lives that you interact with in the web browser. And then just some tokens and NFTs maintained on the blockchain, and maybe some snippets of DeFi logic, which you interact with periodically when you use your MetaMask wallet or equivalent. So we want people to move beyond that way of doing things and actually put all of that computation onto the internet computer, which provides all kinds of advantages, not least getting rid of the decentralization theater, getting rid of the centralization, making these Web3 services secure, making it possible to put these Web3 services under the full, true control of DAOs, where the DAOs actually update the software and it's completely transparent and there's no backdoors, and where you can do more sophisticated tokenization. So that's one big thrust. And the other one we're really just starting out on, which is to get the enterprise world building on what we call Cloud 3.0, which is a blockchain, where they have a number of huge advantages. Their code doesn't get infected with ransomware. They don't need to protect it with a firewall. It's unstoppable. And where they can also put it under the control of a DAO, where the community really is the enterprise admins if they want to decentralize control, and where hopefully they can bring their R&D costs down, which means they can be faster to market, innovate better, and things like that.
I love that vision. And given the advantages that you pretty much laid out there and the optimizations that you're going for, I think it's pretty clear that it's not the easiest problem to crack. And you've had to operate quite an advanced kind of research institute or operation around that for the past years. And I know you've been at it for quite some time now. So do you quickly maybe want to walk me through the timeline of what has happened throughout the years in terms of the development? And has the initial vision for IC changed at any point?
Interestingly enough, the vision's never really changed, albeit the way we explained it perhaps has evolved over time. The history is I'm what you might term an engineering entrepreneur, so I'm very product focused. I'm very into computer science and particularly distributed computing and cryptography. And I first started playing with distributed computing in the mid-90s, started adding cryptography to that late 90s. And actually the last thing I did before the last big thing I did was a computer game called Fight My Monster. And I built that in the UK. I was based in London. And I had to do a lot of work with distributed computing in order to create a backend that scaled. And then that worked out pretty well. It used a decentralized database called Cassandra, not decentralized like a blockchain, but a database that you could scale out just by adding new nodes. And I was very involved in that. A lot of that experience kind of did feed into crypto. But 2013, I got the Bitcoin bug. I'd heard about it before, but never had time. And by the end of the year, I wanted to create a new cryptocurrency called Gamecoin. And the vision was that this cryptocurrency would enable people to buy and sell virtual goods within these games and move the value between games. And I realized that in order to do this, I would need fast finality, and I'd also need the ability to process very large numbers of transactions a second. So this was clearly wasn't going to be possible to copy paste Bitcoin. So I started looking at early proof of stake designs. One was called NXT, and trying to understand them. And I found issues with them, with their designs, and I tried to contact the people behind them and couldn't get satisfactory answers. And I remember that particular one, in order to select the next node, the next block producer, which was called a forger back in 2013, they just took the hash of the block. And I said to these guys, like, if I'm a forger, why wouldn't I just craft the block in such a way that I'm always selecting the next one of my own nodes as the next forger? No answer. So eventually in 2014, I said, look, this is something wrong here. I got to go back to basics, and started researching classical Byzantine fault-tolerant consensus and other distributed computing techniques, the formal math of distributed computing, if you like, and trying to see how it could be repurposed for the blockchain setting. And then October 2014, I proposed this thing called Pebble, which was a cryptocurrency that could scale. It had sharding as part of its design and had very fast finality. And actually, my thinking back then was people could use cryptocurrency in novel ways. So if you wanted to get rid of advertising from Facebook, say, you could set up a recurring crypto payment So every day you would configure your crypto wallet on the blockchain itself to send a very small micropayment to Facebook, which would mean that when you were on Facebook, it wouldn't show you ads. I did the numbers, and at that time it was a billion Facebook users or something. And ambitiously, I thought that surely at least a quarter of them would like to get rid of ads, right? And so that means you've got to be able to process that many transactions a day. So I did a lot of work on that. And I was the first person in the blockchain industry working both on classical Byzantine fault tolerance and seeing how it could be repurposed for blockchain setting, and also the first person proposing sharding architectures. And at the same time, I was becoming very involved with the early Ethereum community. So I distributed that paper, the Pebble paper. At one point, it was on the history page on the Internet Computer. And it only went to industry insiders. So Vitalik Buterin saw it, for example. And initially, that was my plan. Tried talking to some VCs, saw that it was very difficult to raise money for something like that. People didn't really get it. Like, what are you trying to do? And at the same time, eventually came this magic phrase from the Ethereum community, world computer. When I heard that phrase, it really struck me in a different way than it did other people in the Ethereum community. So if you go back to the Bitcoin Miami event where Vitalik introduces Ethereum, there's a bit of it, but his thinking is really like you can put a bit of DeFi code on Ethereum and you can create an ERC20 or an equivalent. My thinking when I heard the word computer is like a light bulb came on. I'm like, okay, smart contracts are actually a new form of software. Smart contracts are a new form of software, and they have these really magical new properties. They're tamper-proof. You don't have to protect them with a firewall. They can't be infected with ransomware. They're unstoppable. Obviously, tokenization means you can process data like value, and they're highly composable. And to me, a blockchain looked like a sort of stateful serverless cloud. And actually, I classify blockchain protocols as stateful decentralized protocols because you've got these networks that are running in a decentralized way that maintain a shared state. And the shared state, of course, is the smart contracts and all their data. And in the case of Bitcoin, the ledger, the UTXOs. So I'm thinking to myself, okay, why can't we build a blockchain that solves these fundamental speed, scalability, cost, flexibility, and so on issues, and then replace legacy IT with a blockchain? And I think my perspective came from being a bit older at the time than other people in the space. I've been coding for several decades already. I started coding with a ZX81, which had like 8 kilobytes of memory or something, and I only had access to it at school once a week or something. So I used to write down my programs on paper and carry them with me and get my time slot and quickly type in the program. And I've been from there right the way through, created like everything imaginable from like network systems, cloud systems, games. And so I'd also used a lot of different kind of software. I've written BASIC to start out, then everything from C and low-level stuff like assembler through to virtual machine based code on Java and things like that. And I'd worked with distributed computing, and I'd worked with clouds, and I'd worked with servers and that. So I had this like epiphany, which is, God, there's so many problems with that legacy IT. And it's all just evolved from this same point really that I started out at myself, which is computers with hardly any power, hardly any storage, hardly any memory, initially no network or very slow networks. And, that's what's behind everything we use, right? And that's why it's so complicated. It's just evolved. But blockchain gives us a chance to rethink what our backend tech platform should be from scratch. And we can leverage all this super, super advanced distributed computing math and cryptography and advances with virtual machines and software design and things like that, and produce a vastly superior platform for the world to use that's a blockchain. Really, it became a kind of cloud 3.0 vision. And in 2015, I started using the word DFINITY. DFINITY is a concatenation of decentralized infinity. And my plan initially was that DFINITY would be, the word internet computer didn't exist at that point, it was just DFINITY. The idea was that DFINITY was like a code name and would become Ethereum 3.0. And so I spent a lot of time evangelizing these different mathematical techniques and approaches and so on, and ways to build new kinds of blockchain. But what became very apparent was that Ethereum was on this incredible trajectory. There was no need for them to slow down and rethink everything from the ground up. And not only that, to fulfill this world computer vision, it would be necessary to develop new math, and that doesn't come about quickly, and a lot of rethink blockchain architecture. So eventually DFINITY became its own project. 2016, started working on it in earnest. I was a co-founder on a decentralized project incubator called String Labs in Palo Alto in California, where I was based at the time. That incubated the DFINITY project. Foundation was created in Zug originally in October 2016. Ran an ICO, for want of a better word, it was an ICO, in February 2017. Got a bunch of money from that. Unfortunately, we were a bit early, so we didn't raise nearly as much money as the projects that followed, but took what we had, produced this prototype by the end of the year. And it was a very impressive prototype using this thing called threshold relay, and people could see how fast the network could reach consensus. And in that first iteration, smart contracts were, you could only code in a subset of Haskell, but it was enough to run a couple of rounds in 2018. And they raised much more money, over $100 million. And then with that, DFINITY really began to scale out its team. So at that point, we had people in both Switzerland and California. And during 2018, we met a guy called Jan Kamenisch, who is now the CTO, and he was leading crypto research at IBM European Research, which is located just outside Zurich. And he pulled a lot of top cryptographers with him. And then we became a sort of talent magnet. Google's second biggest campus in the world outside Mountain View is here in Zurich. It's Google European Research. And we started hiring a lot of people from Google, which actually helped because we were able to import a lot of expertise oriented towards building large-scale complex systems that could not go down. And so that kind of blended with, I suppose, old school crypto enthusiast know-how and thinking. And 2016, we had a lot of great people too. I mean, Timo Hanke, the guy behind ASIC Boost, Bitcoin legend. 2017 or late 2016, got Ben Lin, the L from BLS Cryptography, pulled from Google. Early 2017, Andreas Rosberg, the co-designer and really the lead guy in the WebAssembly universe, and which is the virtual machine, of course, that everyone now wants to use. So a lot of these technologies that are now people want to use in blockchain, the founders actually worked at DFINITY, like BLS cryptography, WebAssembly, virtual machine, and so on. So then it was like, okay, we just scaled up. We weren't really a business operation. We were really an R&D operation, which hurt us later. We didn't have all the integrations and fancy partnership announcements and so on. But we did have an absolutely awesome leviathan of a R&D operation. And it took really until May 21 for the Internet Computer Testnet to transition into production mode and for mainnet to exist. I mean, years and years from the project's inception, but also hundreds of person years R&D, with R&D including blue sky cryptography research, blue sky computer science research, as well as engineering. And yeah, that's how it came into being. And even now, we're by far blockchain's largest R&D operation and have been for many years. And people are always shocked because you don't really hear much about the Internet Computer. They come to the offices here and they're like, wait a second, because if you go into Zug, we moved to Zurich, right? Because that was the best place to situate the research center. But if you go to Zug, you go to Crypto Valley and you go to there's one particular building where you have a lot of the foundations for the big name blockchains you hear about. And you go up the stairs, and there's like a central staircase, and then it's like that's in the middle, and there's like each level has circular surrounding corridors with the offices, and you look into them and they're like just rooms. And for most of the time, there's nobody in there. And people get used to that. And then they come to the Zurich HQ and their minds are blown. It's like a huge 8-story building. And I've had people say to me, blockchain has to be simple so everyone can understand. And my answer is, I understand that perspective, but if you want to create a blockchain that can play the role of Cloud 3.0 and hopefully one day host most of humanity's systems and services and replace legacy IT and deliver these amazing benefits, it's always going to be complex. And even I'm chief scientist and I understand how it all hangs together. I certainly struggle greatly with a lot of the novel cryptography that's been developed. But that's okay because we employ some of the best cryptographers in the world and this stuff's been through a very rigorous process.
Yeah, the biggest R&D operation in this space, but for a good reason, because the vision for the world computer that you have is not an easy one to crack. Now, at somewhat of a high level, because I know this is a topic we could spend hours speaking about, could you summarize what the main technical innovations are that you've kind of needed to crack to enable that vision of the world computer?
Firstly, the Internet Computer is not proof of stake, which might surprise a lot of people. So if you dig into the big blockchains today, mostly they run on Amazon Web Services, and the validator nodes, as they're called, are completely anonymous. You don't know where they're running. It could be some of them have hundreds of thousands of, Ethereum has hundreds of thousands of these nodes. I mean, individuals or companies often run many thousands of nodes themselves. All you really know is that These nodes are running on Amazon, they're running on Google Cloud, and so on in the main part. There are risks associated with that. Solana had like 40% of its nodes on Hetzner, which is a European cloud, and they just switched it off all of a sudden. And 40% of more than 1,000 validators, 40% of the network disappeared. It philosophically for me is a sort of more old school crypto. I don't like the idea of a blockchain running on these big tech centralized cloud services. That's what I want blockchain to replace. But actually, it turns out that it also creates various challenges for creating a blockchain that can scale efficiently and so on. So first thing was this idea of proof of useful work. And the internet computer is created by node machines, which are dedicated hardware owned by independent parties that they install and operate from independent data centers around the world from different geographies and jurisdictions. And these node machines are combined into subnets internally. They're invisible, very different thing to Avalanche subnets. You can't see them. And they host Canister smart contracts. For those that are interested, the reason these node machines have to be built to a standardized spec, we're not selling the node machines. Anyone can build their own node machine, albeit there are people that build them. The reason these node machines have a standard spec is that if one of these subnets was under load, you wouldn't want some of the nodes being unable to keep up because the network could slash them. It might consider they were faulty. So everyone uses the same hardware. So when the network's under load, everyone can keep up. It's as simple as that. And also no hardware goes to waste. It's more efficient. So we needed a way of binding these nodes, and we used a completely novel consensus mechanism that's based on threshold cryptography and a bunch of other things. It's a kind of highly consistent blockchain that's driven by a random number generator. BLS is used to generate the random numbers. And then there's a thing called a synchronous finalizer, which optimistically finalizes branches on the chain. So typically you're getting finality of about a second. And then the nodes participate producing blocks as instructed by this thing called the random beacon, the random number generator. And their task, or the requirement rather, is that they produce the same number of blocks as the other nodes in the subnet. They're not competing to produce more. They just have to produce the blocks they're told to produce. And if they don't, that might be a sign they're faulty and they can get slashed. So it's a scheme of proof of useful work. And we needed something called chain key cryptography that would make it possible for a blockchain to sign interactions, right? And if you want to validate your interactions with the internet computer, you only need to know this 96-byte master key. Now, you as an individual don't know it, of course. It's the user experience, like the JavaScript or the WebAssembly in the web page you can't see. But it knows this 96-byte master key. And it can just, when you submit a transaction, it can just check the signature on the response. And this allows the user experience to know that the transaction was submitted, processed, and produced this response. And it also tells you that the blockchain is running correctly. And this means that you don't need an intermediary, you don't need a local node, which is how you really should interact with a traditional blockchain like Ethereum, if you want to know that it's running correctly and all your interactions haven't been tampered with. And internally, inside the internet computer network, what you can't see are all these subnet blockchains, which combine these node machines from different node providers, different data centers, different geographies, and different jurisdictions, minimizing the replication that you need. So it uses a thing called a deterministic decentralization, which is more sophisticated than the Nakamoto coefficient. And these various subnet blockchains can communicate with each other without seeing each other's blocks because of this chain key cryptography technology that's used by the network. And that's very important because it means that as the number of subnets grows, they're not all having to look at each other's blocks. All they need to know is the correct key for the subnet they're interacting with. And again, it's like a 96-byte key. And what's wonderful is the entire network has this master key. And you as a user can interact with any part of it just knowing this master key. And you can verify everything and check that things are running correctly. And of course, that's just hidden for you in the user experience. So now you have this platform that can be a cloud, right? Because you can connect directly to a smart contract using a web browser. And that smart contract can serve a user experience into your web browser. And so long as you've got a service worker in the browser or some kind of, more ideally, like an extension or modified browser that knows the 96-byte master key, it can just verify all the interactions. And so you basically create like a session. Like when you create a session with a smart contract on the internet computer, it'll typically serve the user experience to you. You'll use something called internet identity to create a session, a secure session with a smart contract. And within that session, your user experience is typically submitting many transactions a second. And they're not for transferring an NFT or something. They're for interacting with smart contracts that are just fulfilling the general cloud-like role of supporting a service. The whole thing's re-architected. As part of that, obviously, there's a probably think, how do you pay the gas? Actually, it uses a system of reverse gas where the smart contracts pay for their own gas. It's called cycles on the internet computer. And you just charge these smart contracts up, these Canister smart contracts up with cycles. And it's like charging a Tesla up with electricity. They'll continue to run as long as they're charged with cycles. They stop, they run out, you can just charge them up and they can start running again. And of course, to scale, you've got the network you can just keep adding subnets, which adds capacity for hosting these Canister smart contracts. And in addition, the Canister smart contracts actually run in parallel. They're called actors, software actors, which I hope I'm not getting too technical, but essentially a software actor maintains its own state, its own data, and they can't directly see any other actor's state. So a Canister smart contract contains WebAssembly bytecode, which is the software logic compiled down from Rust or Motoko, TypeScript or whatever, and it contains persistent memory pages. So you can just persist something. You don't need a database. If you want to persist something, you could just create a new data structure, and that data structure becomes the database, right? It's called orthogonal persistence. And then you can call other smart contracts. You can call their functions. But at the network level, it's reduced to messages, and a message is transferred in a transaction or within a pulse within a certain subnet. And a message carries either a function call or a function result. To the code, it just looks like you're calling a function in another smart contract and you're getting a result. But you can place a deterministic ordering on those messages such that all of the blockchain orders the transactions, right? That's what a blockchain essentially does. It just orders the transactions such that all the nodes in a subnet blockchain are processing the same sequence of transactions and they're seeing the same state, because the message passing, even though the canisters can run in parallel, actually the message passing between them is deterministic. And so the subnet blockchains don't fork. But obviously that's again important because it means that it provides a way to scale internet services. And each of these node machines has a large number of cores, like physical CPU cores, which means that each subnet's able to deliver very high computational throughputs. And it's all of this together. You couldn't really just point one thing that, oh, this is how blockchain became a cloud. Blockchain became a cloud by completely rethinking it from the ground up. And then blue sky research into cryptography and applications of particularly threshold cryptography and setting up threshold key sharing using non-interactive DKGs and things like that, and novel consensus protocols, novel ways of creating a virtual execution environment for smart contracts, working with WebAssembly to get new features into it we needed, reverse gas model, chain key cryptography, so these different subnets can interact without seeing each other's blocks, interact securely. And thus that, because you've got this message passing architecture where these actors are not only able to interact with other smart contracts on the same subnet, but also on other subnets just by passing messages, which also, of course, has to be done in a secure way too. It's all of these things together that enable blockchain to go from being something which can really host little bits of DeFi logic, NFTs and tokens, to something that can host a social network. And this advance is very important. I mean, obviously for enterprise, the benefits of blockchain only really are obtained if you actually run on the blockchain. That's how you create systems and services that are tamper-proof, don't need firewalls, are unstoppable, and so on. But it's also very important for Web3, because once you can actually build your Web3 service, whether it's a game, metaverse, social media, or whatever it is, and lots of other things actually, on the blockchain itself, now you can put it under the control of a special kind of DAO called a service nervous system, which is almost like a source control manager for a code base, but it works for a running system. It runs for a running service. And now I've got a deck. You can get it on the homepage of internetcomputer.org. And one of the systems it highlights is called icdex.io. And it's a fully functional continuous double auction exchange. The smart contract is creating the user experience, limit orders, fill or kill orders, everything, different trading pairs, but it's created by a smart contract. And that's an advance because this one hasn't become an open internet service yet, but it will. At some point, it's going to assign itself to a service nervous system DAO and fully decentralized control. And at that point, all updates to its smart contract code, which is everything, right? The whole thing's a smart contract. There's no cloud stuff. All updates to its software logic, right? And any other configurations will have to go through the service nervous system DAO. So now you've got something that looks like a CeFi exchange, looks like FTX, but it's tamper-proof, you can't be hacked, it's got no backdoors. I mean, when I say tamper-proof, of course, there's no way of getting in and through the back end. You still, with an exchange, you have to do some security audits in your code, obviously. You don't need a firewall. and there's no one hacking their way in that way, and there's no backdoors, and all the updates are transparent. And that's like, it makes it very easy to see some of the advantages of open internet services.
That architecture is truly incredible. And I have to say that I feel using internet identity was for me one of the wow moments that I had during my time in crypto, and just signing in with my fingerprint on my Mac to use things, it's completely frictionless.
It's cool, right? And it's so slick. People think that it's like centralized or something. And actually, it's the most decentralized identity system around at the moment. It's far more decentralized than typical crypto wallets, which are served from the Google Chrome store and so on and so forth. What's happening there is it's using a protocol called WebAuthn, which all the major web browsers support now, that enables you to create and access key pairs stored inside something called a TPM chip, Trusted Platform Module, that's inside nearly all modern devices now, like a smartphone or a laptop. And so when you essentially with an internet identity, you're adding devices as though they are your passphrases. In reality, of course, your passphrase is created anew and it's inside the TPM chip. And when you want to create a secure session, you're pressing the fingerprint, doing Face ID or whatever, there's typically some secure hardware circuitry being activated, and your session is being passed inside the TPM chip where a signature is being added. So that's how it's done on the client side of the user device side. And on the back end, on the internet computer, it's using chain key cryptography to certify a set of these key pairs from your different devices. With a single internet identity, you can have a bunch of devices, and all of them are being those devices are being certified by the chain key cryptography. And it does various cool things, like when you authenticate yourself to a new Web3 service, it doesn't see your internet identity. It actually sees a pseudonym that the system creates for you in order that different Web3 services can't club together and track you across them, as happens on Web 2 or via single sign-on services. So that, I think, speaks to our desire to make blockchain the everything stack, right? Everything is built and runs. But there are complexities, and that's why things go a little bit slower. So if you look at, for example, DeFi on Ethereum, it's a much simpler system, right? So identity is your public key, right? You got a public key here in MetaMask, and you share that with every service that you interact with. Like, you look in your wallet, you see your assets. You go to MetaMask, you go to Uniswap, you see the same list of assets. And if you swap some ETH for something else, some USDC or something, it's immediately reflected in your wallet and any other Ethereum dApp you use. So it's very simple. And really, Ethereum is just one monolithic piece of software comprised from all these smart contracts, and each user is just typically one account, which is a public key. So when you get into the realm of trying to make things easier to use with respect to using a fingerprint, but also at the same time hiding people's privacy, you get some additional complexities. And that's something we're addressing at the moment to make it easier to use within the sort of DeFi realm, while at the same time preserving people's privacy, which of course is very important. But that's where you get the complexities. And once you go the route that we did and re-architect everything, like it's a shared nothing blockchain, even a lot of the cryptography is novel, right? Once you go down that route, RED becomes more expensive, and some things take a little bit longer to deliver and make as easy to use as people are used to, because it's just more complicated. But if we want to see a real true world computer where everything's built, these are the challenges that have to be met.
Got it. And when we think of what apps are best suited to be built on the IC, is it fair to say that you are aiming to facilitate everything that the internet facilitates today, just on a blockchain?
Totally. So I think there are two parts to that. So yes and yes. But we also believe that if you change the foundations, you change the way things are built on, you change what's built on them. So today, modern society is run on these kind of frameworks, digital frameworks that are created for us, whether that's the social sphere, social media, say, or business, or supply chains, or whatever, or medical records. And these digital frameworks are provided by systems and services, which are created using software. And that software and its data has to run on something. And today, that's clouds and this kind of legacy IT software building blocks like databases. But if you can improve those are societal foundations, right? Those are the foundations of our society today. If they break, everything breaks. And so if you can improve the foundations, you can improve the digital frameworks the society uses. So with respect to Web3, this will become very obvious that, OpenChat was the world's first open internet service, oc.app. People can find it at oc.app, and it's a messaging service. And people still struggle to understand this thing runs 100% on the internet computer, on a blockchain. And when, that user experience, super sophisticated user experience that appears in your web browser, that's been created by smart contracts. When you send a text message or a video message or whatever it is, that's being transmitted by the blockchain. I think they do, what is it called? WebRT, the web protocol that can be used just peer to speed up the notifications. The finality on the internet computer is like a second. But obviously, when you're typing, it's very important the other person immediately sees those dots and things like that, right? But essentially, it's 100% on blockchain. And the first difference, therefore, or at least in this case, because it's an open internet service, is that it runs under the full control of a special kind of DAO called a service nervous system. And so thousands of people hold these chat governance tokens and collaboratively govern OpenChat. And the core devs don't have a backdoor. Yeah, there is no backdoor. There's no Amazon Web Services that can switch it off. And there's no backdoor, like the devs can't log into Amazon Web Services with their username and password and start arbitrarily modifying people's data or even the service's logic. Every single update to OpenChat has to be proposed to the service nervous system DAO. And this is a complete framework for updating and running Web3 service on the internet computer. And if that proposal is accepted, like if it includes WebAssembly, then it's applied. People can go back and check the hash and look at the reference to the source code on GitHub and so on and so forth. So it's completely transparent. It's governed via algorithms, obviously. It's an algorithmic liquid democracy system. It's governed by its community. And so it runs like a protocol itself, like an autonomous protocol, a bit like a blockchain. There's no backdoor, there's no outside party that can force its wish on the community. And it's unstoppable. And because it runs as a smart contract, like you're interacting directly with the smart contract. There's no wallet. So of course, you can just authenticate with internet identity and some other services that are popular on the internet computer. But the tokenization is much more pervasive and works in a different way. If you and I are on OpenChat, I've got an account now, we could connect. I could literally just send you a chat message with some Satoshis in it. I can send you some Bitcoin in a chat message. And it's this thing called chain key Bitcoin, but it'll arrive within a second. And once you receive that chain key Bitcoin via the chat message, or your OpenChat also functions as a wallet. It'll show you your balances. You'll see some Bitcoin in your wallet, and you can send it to someone else via chat messages, or you can send it to a native Bitcoin address. And it'll take longer, of course, because the finality on Bitcoin's longer, but there's no limitations. This obviously touches a little bit on the multi-chain capabilities of the internet computer, but we think that once Web3 services become smart contracts, the tokenization can become much more powerful. And there's a project called Hot or Not, which is like a tokenized TikTok. And people are betting on which videos will go viral. There's a new version, I think, coming where you can earn tokens by helping with moderation. And these tokens create a decentralized economy for this Web3 TikTok. And I think they're called hot tokens. And the plan is that in the future, advertisers will have to buy these hot tokens in order to run advertising on the platform. So you create this beautiful decentralized economy, which is possible because the thing runs as an open internet service under the control of a DAO. Essentially, it's an autonomous protocol. And that makes it possible because people are interacting directly with the smart contracts, you don't need a wallet to move tokens around. Everything becomes much more fluid. And that, I think, points the way to the future, like inverting the internet service model. So there's no company, there's no board of directors, there's no CEO. Really, the community of governance token holders that interact with the DAO is the board, thousands and thousands of people. And many users of these services are going to be founderized by them. They're going to do things that are useful, like helping with content moderation or create viral videos or refer other users or do other useful things. Receive, in this case, I guess it'd be the hot token or something, and almost become a startup, like part of the founding team. And through this, these services will build these vast virtual industrious workforces. And the users are now not only owners, but they're part of the team. And I think that's the revolution that's coming. And that speaks to this thing with Web 1 was people just reading content from servers. Web 2, we began uploading stuff to servers, and Hot or Not actually was the original Hot or Not was one of the first. People started uploading pictures of themselves to see if other people thought they were hot. And then Web 3 is about ownership. It's about inverting traditional models and giving people ownership.
Yeah. And to your previous point, my OpenChat username is actually just my first name. It's @Oscar. So we should probably move all chats there from Telegram.
It's which one? Let me connect you. We'll go through it and I'll send you. I've got some Bitcoin in my account. I'll send it to you. It's so easy. You can't even believe it's happened. By the way, talking of chain key crypto, something people may be interested in is that it behaves like a digital twin. And there's work ongoing at DFINITY now to make it much easier. So there'll be like a gateway page where people can just take their Bitcoin or Ether or whatever it is and just put it in and just get the chain key twin and use that within Internet Computer Services. But there's also been a technical proposal for a way of literally making it completely fluid. So we'd create a special kind of Ethereum wallet, and the wallet actually would be controlled by the Internet computer. And the balance, amalgamate all these balances on the Internet computer, which would act as a kind of layer 2. And if you got this wallet, you could use your Ether and ERC20 tokens without any impediment on Ethereum. So you wouldn't be losing anything. But if you use this special Ethereum wallet, which is hosted by the Internet computer, you would automatically get chain key twins. So if you deposited 100 ETH, you'll now also see 100 chain key ETH. If you deposit Uniswap tokens, you'll see equivalent amount of chain key Uniswap tokens, and so on and so forth. And you can use them both in parallel because the Internet computer is now the sequencer. And of course, it knows both what your correct balances of ETH assets should be and what your free balance of chain key assets are. So that's what we're looking at. It's going to take a while to get to, but eventually these chain key capabilities, because they allow Internet computer code to create transactions on other blockchains, that's how the chain key Bitcoin stuff is created, we can drive an incredible level of fluidity. So not only is there no bridge, because everybody should know by now a bridge is centralized and insecure, right? Not only are there no bridges, and they're not only insecure, by the way, they're also like cumbersome and a pain to use. Not only are there no bridges, but there's this level of fluidity where you can just use a special Ethereum wallet and all of your Ethereum assets are simultaneously present on Ethereum and the Internet computer. And it deals with the differing finality times so that even if you're updating your balances on Ethereum by using Ethereum DeFi, the chain key, the system will keep track of which part of your chain key balances are unlocked, free, safe to use, outside the 12-second finality window. So there's no barrier. You can see your Ethereum assets. You can use them immediately. You can see your chain key twins, and every Ethereum asset has an equivalent balance of chain key. You can use it immediately. Like there's no barriers beyond some necessary syncing for finality times, but essentially it's completely fluid. And that, I think, is another aspect of the Internet Computer Project, just trying to deliver the original world computer vision, or at least the world computer vision as I understood it. And that includes not only a blockchain behaving as a cloud 3.0 that you can build anything on, but also linking together all the different blockchains in the world without bridges, just making it completely as fluid as it possibly can be, which also is important, I think, for there's already people running AI on the Internet computer. I believe there's already an AI smart contract running on the Internet computer. It's also going to make it very easy to call into AIs on the Internet computer, AI smart contracts on the Internet computer from other blockchains. And I think that's going to be important going forward too.
100%. And I can't wait to see how everything continues developing here and as you start getting more and more adoption as well. But as we're reaching the hour mark here, I know I would love to speak with you for 3 more hours because this is such a fascinating topic, but maybe we'll save that for another time. I might have to come check out your impressive R&D, 8-story R&D operations up in Zurich at some time. But thank you so much, Dominic, for this comprehensive overview, the basics around Internet computer. And I hope we can do it again at some point.
Yeah, thank you.